Hi there. Hi, hi everyone. Uh, so I hope this is gonna be our last tutorial for week one. This is last time yeah we have been covered the Python data structure types, and among them, like, we just covered tuple. Okay, and we did tuple exercise. Now let's start today's, like, lists. Okay, what is list? A list is like a tuple. It's built in Python data structure. It uses, like, store multiple items, you know, in a single variable. Okay, and lists are ordered. Their meaning items have a fixed position with index. Lists are, like, mutable. It can be changed. List elements we can add, remove, and so on. So their elements can be changed after creation. We can create empty list first, and we can add just elements later. Okay, this is the feature of, like, list. A list can also store different data types, like number, string type, and boolean types. Okay, like logical data types. Okay, list elements are accessed using index numbers. There is positive index, negative index. Okay, so we can access an element from the list based on their indexing number. Okay, and also lists are created using a square bracket. Just list use with a square bracket, and list allow duplicate values. We can duplicate values many times inside the list. Okay, common list operation, we can add elements, we can remove elements from the list, we can just update elements from the list. Okay, so uh, let's see Jupyter book. Let's open this one, and uh, so we can run like this. Here is the list with empty list, or just without element here. So we can add elements. We can, if we just run this one, it prints just empty space. Okay, and create a list. Look at this list definition with square. So we can add lists. Here is string type, right? String type elements in the list. Okay, so we can print the list, and from here you can see this is also from here up to here, just, yeah, constructed from iterables such as tuple. Like, here is a tuple, right? From here, this list is a square bracket, so here is a tuple. So change tuple into a list. Okay, we can change this one using this list. We can change this tuple into list. Okay, and range, from, right, range start, stop, and stepping. So range, like, from 0 up to 5. 0 is starting, 5 is stopping, but step is what are the, the consecutive numbers, 1 up to 5, like jumping by 2, jumping by 1, jumping by whatever. Just that is, we can call it step, okay? Based on the steps. If there is no step, by default range like starts from like 0 up to 5, means like it lists like 0, 1, 2, 3, 4, not including the last one. It should be excluded like this, okay? So range list, so you can check it out, guys. You can check it out, this part, okay? This part, simple exercises, simple examples. If you maybe need some more detailed explanations, yeah, you can chat me. And let's check the exercise, okay? Let's check the exercise part, okay? Let's see, exercise, list exercises. Okay, let's download this part and open using, okay, come on, download list exercises. It is a list exercise, so open this part and let's practice. So just patient, guys. Okay, I hope, okay, till then let's see here, let's read here. Yeah, we'll come down. So exercise 1 says like, suppose we want to label trees we plant in our plantation, okay? We're gonna label the trees in our garden using integer numbers, using just integer, kind of like the data types are integers, okay? Integer. Let's create a list containing integer from 1 up to 5, named first tree. Here is the variable. Our variable is first tree, and then we're gonna list, let's check this one, we're gonna list, yes, come on. So let's, yup, let's here is, come on, suppose we want to label them, means like, let's uh, create lists, create lists. Our variable is this one, first tree. So list, we use square bracket, right? Square bracket. So what about the list here? 1 up to 5. 1, 2. There is no step, right? Just we got 1 up to 5, just simply. So the step by default is 1. That means the different, the two consecutive like elements, 4 up to 5, okay, up to 5. Here is our list based on this one. So print first the variable trees. First trees. So see, see. So in another way, maybe here is simply list method. We can use even range. Okay, we can use range inside the list. So let's use copy this one to make life easy. Here is the variable, and this one we can use like range from 1 up to 5, but 5 is not inclusive in this case. So to to make 5 inclusive, we should use 6. Okay, and then change this range function into list. Okay, list, and then let's see the print. See, same result. Okay, and so there are, this is yeah, next. So our plantation has expanded. Look, our plantation has expanded a lot in the last few weeks. We need to create a list of 3 planted within 50 centimeter of irrigation just irrigation device. Within the planted within 15 centimeter of an irrigation device. Create a list called tree list, starting 20, ranging to 140, in increment of 4. Okay, like 20, 24. Okay, increment, that means increment is the step, right? The step. So let's write our code here. Our variable, or like create list. Okay, 3 list equal to, yeah, equal to, we can do both different methods, like this, in this way, or in this way. Okay, so list, okay, range from 20 comma up to what, 140 to 140, increment by 4. 140, look, this means like 140 not included in the list, so we should use comma, no, okay, 4, there is this step 4, this one is starting, this is stop, and here is the step. So the list will be mentioned 20, 24, 28, 32, 36, 40, 44, like that. So until, so let's add one step. Okay, but the list will be mentioned up to 144. Okay, so I think this is very easy. Instead of using this mention, because we should mention up to 140 in this case, but this is very efficient. I think try it for us. We know the step, the difference between elements each consecutive element's difference is 4, because the increment is 4. Okay, the increment is 4. Create a list called list tuple. So let's print 3 list, and then let's see, I think, great, awesome. You see, 20, 24, 28, 32, 36, 40, up to 140, not 44. It's incremented by 4. Okay, the range starts from 20 up to 140. Yes, why we did like 144, increasing just one step at 4 means increasing one step. If there is no increment mentioned here, we can use like this. Okay, we can use it instead of 140, 41. Okay, just by default there is the increment or the step is 1. Okay, let's run this part. See, 20, 21, 22, 20, just the difference between two consecutive elements in the list is the step. So by default it's 1. By default it's 1. Okay, so let's go. Okay, okay, uh, okay. So let's back in the fourth step. So here is based on our question, it should be like 44. Great, this is all about the question, and let's go to the next problem. We decided to install irrigation for three order, you know, three order, like three older trees that were planted long ago. Create a new variables called combined trees by combining our existing list tree list with another list old trees, like this. Your list should now contain 35 elements. So it is also combining list, combining lists. So the old tree, look at this, the old tree, come on, this part, old trees has three old tree that were planted long ago, and create new variable which is called combining trees, combining combining trees, like tree list. Okay, combining tree and our existing tree list in the above. Okay, the above we had, yeah, we have tree list, right? Concatenate with the older tree. This tree. Let's say, I think tree list is, I think this is for, yeah, let's see first. Yeah, I just skipped this. Yeah, this came here. What is this? Okay, when we created our irrigation tree list in here, we forgot about a tree that's watered by an older irrigation system. Append the number 400 to the end of the tree list. So we're going to append or add this 400 into this list. Okay, so append the element in the list. Okay, so in this case, bring this variable equal to append it. A new variable we can, yeah, actually, of course, append append, you know, append like the new element, this one, 400, right? 400 is a new element, so print, nope, okay, print and list tree list. Let's see the append tree list. Exactly, we can append 400, like it was, there is no 400 in here. Now after we append, or yeah, after we append this 400 into this list, yeah, print, yeah, it's updated, right? It's updated, it add 400 as an element. Okay, and next let's see. So all the trees are this much, combined trees, this list tree plus older tree, and then print the combined trees, and let's see. Oh yeah, look at this. So until this, it's tree list, and the others are older lists. So we can add like this, concatenate. Okay, we can like add lists. How we can add lists like this? We've been using this like for a string as concatenation method. Now it's fine. We can add elements to the existing or the previous list. Okay, so yeah, that's fine. So next, we're interested in creating a list of lists. Okay, so we're listed in creating a list of lists or nested lists. That means if we have some lists inside the list, okay, if we have, look at this, it is one list, it has a string element, right, string element, and another list we have also string elements. So we can add this list inside the other list. Okay, that is list of lists or nested lists. Okay, that we call it nested lists. So let's combine. So we are interested to creating list of list or nested lists. we have two lists of seed production plant. Okay, the first one is conifers and cycads. Given this list is in the code block below, create a variables called gymnosperm. Okay, here is. Let's take this part. Okay, let's take this part. Okay, let's take this part, and we should combine the lists. Okay, create a list. Okay, create a list. Sorry, create a list and bring these two lists. Okay, bring these two lists here. List 1, comma with another list. List 2. Okay. Okay. So here is how we make lists inside the list. That means we have an gym gym gymnosperms, the new list which contains the above two lists. Okay, the above two lists. So let's see. Print this list and let's see what it looks like. Okay. Oh, cool. So look at this. So here is our list, but inside this list there is two lists as an element. Okay, as an element 1, element 2. If we access with an index, here is 0 index, here is 1 index. That means there is two elements inside here, but such elements are endless by themselves. Okay, that's cool. That's cool. And so go to here 6, like we're specifically interested in planting cycas and sago palm. Interested to plant them. Use indexing on this list. Okay, from this list to create a new list that consists of cycan and sago palm. So let's new maybe, or list equal to let's get this cycas, right? Cycas means like here. Cycad means the second element, right? Second element means from, look, from this variable access the second element means index is 1, right? Index is 1. And from here, from this element on this list, on this big list, we can access this one. And then we're specifically interested to planting this sago palm. Sago palm is inside this list again. How we can access this one? From this list, here is 0 up to sago palm, means 0 up to 0. Here is 1, 0. Here is 0, 1. Right? So let's access this part from 0 colon 1, but 1 sago is not inclusive in this case, make it like 2. Okay, so let's see what it looks like. So let's print this, and okay, let's print. Great. See, use index on the last list to create a new list. So we're going to create a new list that consists of this and this. This means like from here to here, from 0 up to 2. If we make it 0 up to 1, what will be happen? Look at this. What will be happen? Only this part. Yeah, it's not a list. Just so it includes sago palm. It should include sago palm. So we should use two, and then we can access. Here it is. What the question 6. So yeah, there is also another number 7. Okay. So what it says, like, we need to combine the plant with this one and this one, the two above two lists, the first two lists. Okay, the first two lists. Where are they? These lists. Okay, converse cycads. Okay, so we need to combine the plant within, combine lists. Okay, combine lists with this and this lists, then sort them alphabetical order. Yeah, so let's sort them. The order, the elements should be sorted. Create a list ordered plants, alphabetically ordered. To store them in, like, hint, the list variable should contain all plants as individual elements before sorting from here and here. Okay, so let's make a new list equal to this and this, right? Let's combine. How to combine the list? By using add, right? We can combine the two lists and print new list. And let's see. Look at this, the new list. They're combined, not like list. They're not. Yeah, it's not like nested list. It's just simply list. They just combined. Okay, combined like this. Okay, and okay, solution. I think you can check the solution. Can run, and yeah, if we made some mistakes, please correct us. Okay, let's go to let's go to let's start. Okay, exercise. Yeah, sets. It's also another, yes, another data structure type. Okay, so sets data structure type. So sets are data structure type. I think it's okay. Okay, let's download this one. Sit, and there is a sit exercise here. Create. So go to here, sit. Okay. Yeah, just wait. Okay, till then maybe let's go here and let's read. So in this notebook we will look at how to create and some with manipulated sets. Sets are sets are using like the curly bracket, and so we can create set by assigning group using like comma, group of values, uh, curl bracket. So we can also construct set from another iteration list from list. Okay, so we can change, here is the list, then change to set. Okay, so you can see here is our list. Let's run this part. Nope, this one I think, yes. So let's see this example. I hope, look at, yeah, you look, the sets are should be right in this form with curved bracket, and there are different types of sets. So we can pass the variable with this data type is, this data type is a set, so we can check that. It's uses like a membership in a set. Set, yeah, doesn't support, it's unordered actually. It's not like order like list, tuple, it's unordered. And set is, yeah, we're not gonna use index to access the set elements. Okay, it's totally different. Duplication, yeah, it's not, set does not allow duplication, so we cannot duplicate. It will be like, look at this, lion, tiger, bee, hawk, fox, and lion. Here is two lion elements, so look, it will be print only one line, not allow duplication. So so sets are mutable but unordered, so we can modify, we can add elements like by updating, using update, like we used yeah, we used like uh, append for the list, we use update for, what is that, for this set. Okay, so you can check these examples. So let's go to exercise. I think it's better to do exercise part because you can check them by yourself. Even the exercise has the solution, but the discussion is what, maybe, I hope, I thought like you're gonna get some hint maybe when I just sometimes I'll just try to explain some reasons, you know, when I do, and how, you know, we should be critical thinker, we should be like problem solver, you know, mindset. We have to have a problem solver mindset. Okay, no, let's, if you practice these problems again and again, again and again without saving the values, I hope you'll get something, you know. Let's do set. Okay, cool. So say dictionary, and we're gonna jump to the code challenge. Okay, so it is uh I hope okay, let's see until the end. Let's read the problem. Yeah, that's cool. We're not gonna waste our time. So look at this. Here is the first exercise. Our forest rehabilitation center contains various trees. Okay, our forest rehabilitation center or center contains various trees. To make sure we have all species covered, we have as much as possible, yeah, a lot of species. We have to determine which unique tree we have already planted. Okay, that means like set doesn't allow duplication, right? So which unique tree we have already planted. So for this, creating a list. Look at this. So convert provided tree list to a set. Provided tree list to a set. Tree set. Tree list to tree set. Okay. And confirm that our new variable is a set. Cool. So it was like the first data structure is list type. So we're gonna convert to a set. Like set and have circle bracket with the list tree. Okay, print the original variable as well as our new variable, both. Okay, cool. Let's write here. Go to our code. So come on here. Let's write our create lists like tree. So we're going to make a tree set, right? This part. Okay. See this part and set, change it to set, right? We should change it to set this tree list. Cool, right? We changed. It was uh like it was uh set, yeah, it was list, right? It was list. This one, here is the list, so convert to set. So our set variable is here with set. Okay, so I think it's convert to this list convert to set. Yes, cool. Okay, if we print this one, definitely we can see what is, yeah, we can see maybe data type. Let's first see print type let's see, 3 set. Let's see this part, what will be types of, yeah, data type. Let's check first the data type. Oh, imply, I think I missed, yeah, one bracket curve. Okay, print this part. Oh, can't see any result, man. So type 3 set print. Okay, I think, yeah, so convert the provided tree list to set. Okay, we converted this one and confirm that your new variable is a set. Confirm that, like print type 3 should be given, like should be oh, it should be like set in Berg. Okay, name 3 sets not defined. Okay, I just 3 set 3 set 3 set 3 sets this part. I see. Oh man, it should be list, right? List. Great. So data type is set. This data type after list convert okay, convert to set is like it's set. Okay, the type is set. Okay, and then print 3. Let's print the first one, this one, I think, and let's see, because it says print original variable means this one, the list, and as well as the new variable is the set. Okay, 3 list print. Let's see the print. Okay, here is the original, this variable. Okay, let's the new one print. The new one is this part, right? This part. The new one is the set part. Let's see how the set looks like. Huh, it's curved bracket, right? It is the list. It's square bracket. It is the, yeah, here is the list. Here is the set. Okay, so let's continue. Compare, like compare the number of elements 3 list to 3 set. Compare, just comparison. The number of elements, just number of elements. That means the length of this one and this one. Print the number of elements in each. Okay, find number of elements. Compare. Come on. Come on. Okay, number of elements. Compare list elements. Yeah, I think, yeah, of course. Let's copy 3 list, exactly 3 list elements equal to len of 3 the first variable, the first list. Okay, let's see. Come on, not print. So 3 set, the second variable, 3 set elements equal to len 3 set. Cool. and then we can print and see. Print, no way, print this part and see the number of elements inside the tree list, and print this part, print this part. Okay, and run. Let's check. Oh, look, print list elements are 13, tree set elements are 11. We can count 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here is like set. Okay, what about the list? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, that's count. So we can count like this. Okay, and what about uh question 2? Problem 2 is like a conservationist recently spent 2 days in National Park, South Africa, and was written down 3 types in notebook. Each of the day was captured separately, and we need to create 2 variables for this tree. One variable is day 1 trees, and the second variable is day 2 trees. This variable day 1 capture the following trees. This all variables. Okay, so we can make this one variable to create here. One variable is very easy, I think. Nope. One variable. So we're going to make a set, right? Set curly bracket and copy this all. Huh? This all. Okay. This all. Okay. This one variable using comma, but we should use in this case quotation, right? Because here is text, so we should use like here is elements, so elements like they're not numbers, they're just strings, so we should use like this all elements. Okay, and print, and then print day 1 trees. Okay, like that. Okay, but make it all commas, like quote in quote, quote in quote, quote in quote, all elements, and then you can print. Okay, you can print, and you will see the result. Okay, what about the other insert here? It is also using command above. Yes, command above. You can use union, like day 1 tree and day 2 tree. Union, use union results. So we can write here union result. Copy this one as a variable. Union result equal to day 1 combine, like day 1 and day 2 you can use. So we should create a set called union. Okay, this is a set, so use this by using union. Okay, make it union with like day 2. Okay, day 2, come on. Okay, and then yeah, you can print and see the result, the union variable. It is a union variable because we didn't finish this part. Yeah, this part, that's why I couldn't print this one. Okay, like that you can do, and we can create a set called both days. See, both days, that means both days. So in both like day 1 trees and day 2 tree, that means kind of intersection, right? Intersection, create both days. Okay, in this case you can use do intersection. Okay, intersection both days, like both. You can bring, yeah, it is both days, take as an variable. Okay, hope I think I didn't copy this one. Okay, both days equal to like day 1, this one, come on, this one, come on, dot intersection day 2 trees, just tree. Okay, so you can run and then make it print and see both days. Okay, come on, like, so you can run. And what about this one is like you can do the others. Okay, what about this one? I hope it's like determine whether all of the elements in the following variable. Here is the list, right? Sorry, the set, right? 1, 2, 3 elements, hardwood tree. So determine the element from the variable hard tree are containing day 2 trees. Okay, let's make it hard tree. Yeah, it's wood tree. Okay, make it the elements wood tree, kind of wood tree equal to, like, it's yeah, not equal to, actually it should be subset. Okay, or it should be is subset of like day 2 trees. Okay, so you can run and you can print this part, like we can see, maybe you can make it. Okay, determine whether all of the elements in the following variable hard trees are combined. This one, ideally we would like to run a single common hardwood tree is subset of this one, so we can new in here and print new, and you can see. Okay, run this part and just check a result or result with the solution. So, and what about next is let's go to think our next dictionary, right? What's dictionary? What is dictionary? And let's do dictionary exercise. I think this is our last data type, data structure type. So this a dictionary is like same as like tuple, set, list. It's built-in Python data structure, which is used to store data in a key value pair. It's in this case the elements are pair. Key the first and then values. Key the first and then values. Just the pair values. Dictionaries are unordered, like it's items we can access using keys, not like using index like list. Okay, we can access the dictionary items using keys. Okay, key and not the value, not index. Dictionaries are mutable, so value can be changed, add or removed. Each key must be unique, right? So in this case, the key should be unique, but the value can be duplicated, okay? Can be changed. A dictionary duplicate means, for example, different keys will have the same value. Okay, will have the same value. But key, yeah, couldn't be repeat, okay? Couldn't be duplicate. A dictionary can store different data types like uh, both like key and values, okay? It can be string, can be number, whatever. It can be string with number, different data types. Dictionaries are created using like curl bracket, okay? Curl bracket. Look at this. Using curl bracket with key value pair, okay? Key value pair. Let's download this one. Oh, yeah, I think this is example. Okay, I'm not gonna yeah go through this one in detail because it's example. And dictionaries are commonly used to what represent real-world data, like records of recording or configurations. Okay, so it's good. So let's jump to exercise and let's see. Okay, let's see. Jump. Exercise. Okay, come on. Hope let's download this part. Okay. Yes. Dictionary. Where's dictionary? Come on, man. Yeah, this one. Here's our dictionary exercise. Let's see. Let's do exercises, okay? Okay, until then, let's read the problem here, okay? Until it open, let's do. So exercise 1 says create a dictionary called tree. Dictionary name will be tree with the following key values pair. So we're gonna code here, okay? And the same value tree type paper bark tree. That means here is the key, tree type is the key, here is the value, and age is the key, here is the value 15. family is the key, kernel sees the value, so they're just key value pair. They're pair. Okay, this dictionary. Okay, let's go here. Dictionary key pair value. Okay, so and then print the value associated with key edges. Okay, cool. We're going to print. Okay, we're going to print them. Open. So let's understand here. Let's write like the variable is 3. So write 3 equal to open curl bracket and copy 3 type with this one and this one with comma. So we use like say we use quotation. Okay, quotation, quote colon, quote the value, quote age colon 15. There is no need because it's a simple number, right? So comma and quote family colon quote this part. Okay, it's right like that. My goodness. So let's write code here, create dictionary. Okay, create dictionary. Boom, create dictionary like the 3 is our variable and open curly bracket, copy this part. Okay, code. So look at this code colon and colon. Yeah, just close quote in quote comma, bring this part. Okay, use quote in quote colon quote his key value. Okay, that's why we use comma then like this. Okay, and third quote family quote colon quote Conelasi. Oh, great. So closed curl bracket. Okay, and then see print 3. Come on, print 3. Let's see what it looks like. I don't know exactly. I think I did right. Should be print this out. Okay, should be print out this. Okay, what's wrong? I don't know. Yeah, it's a I think connection problem. It will be print. Anyhow, we can do like that. And second one is print the value associated with the key the value key age. Look at this. Print the value associated with the key age. The key age, what is that? Huh? Tree type. Oh, I think this one's, oh my goodness. There was like age. Come on, man. Sorry, I did some mistake here. Come on. Oh. Come on. Come on. So age. So 15, right? 15. So let's run. Yeah, that's great. Yeah, I made a mistake here. Yeah, because why that was happened, like, because the key, there was same key, three type. Okay, that's why. But keys are keys should be unique. That's why. So print the value associated with the key age. Key age means the value is 15. So we need to access, 15. Like, we can use different methods. Simply print, like, we can use format method. We can use f string, like use f age. Yeah, we can make it cap, maybe. Age is like, we can create three, like okay, the variable, the key value here, the key, like we use index value, age. Okay, curly bracket, close the f string, and let's see, I think, yeah, okay, this, something's wrong here. Yeah, it's print value, right? It's print. So use this one. We can access 3. Yeah, let's close this value in here, 3. Okay, what is that? F string, code in code in code is another. Yeah, it should be coded, okay, here, because single or double quote. So invalid syntax, perhaps you forgot a comma. Of course, where is, oh, comma, yeah, where is comma? No, not comma, this part. Yes, yeah, age is 15, we can access like that. Okay, so next part, you can see, like, when we have fold, the people are no longer interested in one key value pair. So you can, similarly can do this. Okay, So I think we have a solution here, and then yeah, we have even another options, so you can check this part. Yeah, I think you can do first there and check the solutions here. Okay, so I hope, yeah,